Hello everyone, my name is Jacques Zeevaart, and today I will be presenting to you the updates on my senior thesis' concept development, designing for wildlife monitoring. So let's just do a quick recap on the problem statement and hypotheses. My problem statement is to improve the current trail camera monitoring experience, especially in areas where tree mounting is difficult. So areas like this include the desert, tundras, savannas. And the hypothesis is to improve camouflage, theft prevention, field of view, and the mounting process for monitoring in these treeless areas. But why are we picking trail cameras as the tool of choice for redesign for wildlife monitoring? Well, trail cameras are the most commonly used tool amongst wildlife enthusiasts and scientific researchers alike. And trail cameras also present the benefit of being the least intrusive method of monitoring currently available. Because of this non-intrusive nature, they are also the most effective when monitoring shy and nocturnal animals, as opposed to monitoring with a drone that's loud and noisy, or putting tracking collars on animals, which requires tranquilizing them first, and so on. So how do trail cameras work? Well, they're comprised of a motion detector, batteries, infrared emitters, camera lens, user interface, and a tree strap. The motion detector is right here. That triggers the camera when wildlife walks in front of it. The batteries are down here. That determines how long the camera can operate for multiple weeks. And the infrared emitters, which enables night taking pictures. The camera lens, which determines the picture quality and field of view. And the user interface, which is used to program the camera and change settings such as capture speed between shots, and where you turn the camera on and off and have the SD card. And another reason I chose trail cameras is because the global trail camera market is expected to grow at a compound annual growth rate of 7.1% over the next 5 years. So take a quick look at the current treeless mounting process for trail cameras. Currently in treeless areas, trail camera users resort to mounting their cameras on mounting posts. And as you can see below in these pictures, this is a very physical and not very portable process. Process is segmented into 3 parts: transporting the mounting post, preparing the monitoring site, and securing that post. So due to their bulkiness and their heaviness, they can become rather hard to carry on foot. Usually users will transport these posts as close as they can to their monitoring site, but for the last 100 feet or so they have to be transported on foot, and that can be really challenging when you have a big heavy log to carry, as seen here. And then the next step is to prepare the site, and this usually involves digging a hole to lower that post into. It's exhausting, and it also requires using a shovel. And then securing the mounting post, you have to lower that post into the hole and hammer it deep into the ground, which is again very exhausting and requires using another tool. So how can we improve upon the setting up experience? Well, we can improve the portability, we can improve the physicality, and we can improve upon the amount of tools needed to set up. And so for portability, design should be able to be comfortably carried on foot, maybe fit into a backpack or compact to a smaller size. Has carry handles for easy carrying maybe. And then reduce the physical stress involved in the treeless trail camera experience, and minimize needing those large tools like the hammer and the shovel. And maybe if tools are to be used, They're smaller tools such as screwdrivers or easily transportable tools of a smaller nature. Besides improving upon the setting up experience, trail cameras themselves also have three main areas where they can largely be improved upon. Because poachers and trespassers find trail cameras sometimes, they end up stealing them because they need to discard of that self-incriminating evidence. For camouflage reasons, they're also prone to theft because, as you can see here, these trail cameras, the majority of them, have this block-like form, and that doesn't really camouflage very well in natural environments where there aren't a lot of right angles and straight lines. And then the field of view is also an area which can be improved, because when trail cameras are mounted to a tree or a post, they usually only face in one direction, and they don't get the chance to capture all the wildlife that may be around them or behind them. So to improve upon this, we can design an anti-theft feature to discourage thieves or make the theft hard, give the camera a more organic shape to camouflage better, and strive to enable 360-degree monitoring and capturing circumference. Meet Daniel Muir. He's the persona and primary user of treeless trail cameras. Daniel is a 28-year-old ecologist living in Sedona, Arizona, and he has a passion for nature and wildlife photography. Daniel often uses these trail cameras for ecology research in the Sonoran Desert to understand wildlife populations. And when he goes out to set up his trail cameras in these areas, he values having a setup that is very portable but also well camouflaged. Daniel's main pain points are carrying that heavy equipment into the wilderness, being unable to optimize the efficiency of a single camera by monitoring 360 degrees of an open area, and being anxious about his cameras being discovered by thieves or deterring animals because of weak camouflage. Here's the design criteria, segmented into the 4 areas where we're trying to improve upon the trail camera experience in treeless areas. For the height requirements, the device needs to be able to extend up to at least 4 feet from the ground, as that is usually the height between 4 to 5 feet where ecologists and trail camera users place their cameras to understand the general wildlife diversity. For the setting up experience as well, we're going to eliminate the use of those large tools like the shovels and hammers, and ideally keep the total weight below 30 pounds for comfortable carrying. Maybe give the device carry handles or make it small enough to fit into a backpack for portability reasons. For camouflage, giving the form a more natural shape to blend into the natural environment, giving it a color that matches that of the nearby rock, sand, plants, and multiple cameras for expanding the field of view, secure anchor for anchoring the device into the ground and making theft a challenge, and giving it a defense mechanism for theft prevention that is triggered when a possible theft is occurring, and it can fight back against that theft. Before sketching, I use mind mapping to think about all the features that would address user needs and fit into my design criteria. So I made a morphological matrix here that is comprised of all those 4 areas, and I listed out features that would fit into each one of those areas. After doing that, I mapped them out with mind maps and used these mind maps to inspire me in my ideation sketching. So here's a ideation sketch page. I started with small thumbnails up here and then progressed to ideating on camera modules, expanding mechanisms, and base anchors. Just to make sure that I was covering every aspect of what I'm trying to improve. So here on the camera modules, as you see here, I'm trying to think of camera modules that will allow for 360-degree monitoring. Thinking about these expanding mechanisms, need something that's going to fluctuate in height for portability and be compact enough to carry. And then ideating on the base anchors that will secure this thing into the ground and make it hard to remove by thieves. Here's a second sketch page. So what I would do after ideating on the camera modules, expanding mechanisms, and the base anchors, pick a camera module, pick an expanding mechanism, and pick a base anchor, and then ideate, take all of those three to build myself a ideation concept. And here are some of those concepts all together and how they evolved into my three concepts down here: the prickly pear, the saguaro, and the San Pedro. So yeah, let's talk about each one of these concepts a little more. The prickly pear is a stackable modular design that can be built to the right height with multiple camera modules. The saguaro is a telescoping tube with a carry handle. You fill the bottom half with nearby rocks and sand and then attach the top half at the desired height. And then the San Pedro is an accordion-like mechanism that separates the anchor base and the camera module, and it compresses and for easy transport and then extends again at the monitoring site. So when we take a look at the prickly pear, it addresses improving the setting up experience by having an anchor spike that screws into the ground, which then has the camera module attached to it and locked into place. Then that's repeated for another camera module that goes on top. The theft prevention, it's got sharp spikes that are only removable with a sort of socket wrench, specially designed to go over the spike head and unscrew. And it also has a built-in alarm system that is triggered by an accelerometer when it detects that a rapid change in movement has occurred. And that is armed and disarmed through the use of Bluetooth with a smartphone. And for camouflage, well, it looks like a cactus, so it should blend well into environments like the Sonoran Desert. And for the field of view, when two of these units are stacked on top of each other, 4 cameras face every direction, which enables 360-degree monitoring. For the saguaro, setting up, you screw it into the ground and fill the bottom half with nearby sand and rocks to make it really heavy. And then you attach the top half and screw it tight with those spikes, much like the prickly pear that you can only remove with a special socket wrench. And then for theft prevention, hopefully with the rocks and sand in there, it's heavy and difficult to move. And then camouflage, it looks like cactus. Field of view, it has 4 cameras that face every direction. And for the saguaro, also uses that anchor spike, telescoping pole, and then the camera module in the base can fit in a backpack and be transported to the site. And for theft prevention, it also has the alarm system like the prickly pear, and this base is also filled with sand and rocks to make it heavy to move. Camouflage looks like a cactus, and it's got 4 cameras that face in every direction. So my next steps are to refine these concepts, create prototypes in full size, add color finish material, do my SolidWorks, do some renderings, engineering drawings, and make a final model. Thank you for your time. Please feel free to reach out to me if you have any questions using my email, my Instagram, or my website. Thank you very much.